Hello everyone, my name is Ishant Kumar, and today we are going to discuss a problem, New Year candles. It is currently 1000 rated on Codeforces. It is an implementation problem. So let's read the problem. Wesley, the programmer, loves romance, so this year he decided to illustrate his room with candles. Wesley has eight candles. When Wesley lights up a new candle, it first burns for an hour and then it goes out. Wesley is smart, so he can make the went out candles into a new candle. As a result, this new candle can be used like any other new candle. Now Wesley wonders for how many hours can his candles light up the room if he acts optimally well. Help him find this number. So basically, the problem is asking the maximum amount of hours up to which he can use the candles, keep reusing the candles to light up his room. Let's see the constants given in this problem. So as an input will be given A and B. A will be the number of new candles and B will be the number of burnt out candles which are required to make a new candle. A is going to be the new candle which will be initially given, and after burning all A candles we can make a new candle using B candles and use these B candles as new candles. We'll discuss about it. As an output, we have to give a number of hours Wesley can light up for. It is like the maximum number of hours up to which Wesley can light up his room. For time limit, we are given 1 second for per test case. So let's discuss what the problem is trying to say. So initially, we are given A candles. Every candle burns for 1 hour. After 1 hour, that candle is not becomes wax, but wax can be reused by molding it into another candle. That's what we are going to do. But to mold it into another new candle, we required B burnt candles. That's what written in the question. Initially, we are given A candles, which burns for 1 hour, but after burning for 1 hour, it becomes wax. And to make a new candle, we need B burnt candles. B will be an integer given in the problem. So we'll need B burnt candles to make a new candle, which will be another A. If we use B candle, it's like uh, from A we are going to B, which is burnt candles, and from B we are forming A. We are recycling all the wax into A and reusing it. So we are going to, as an output, we are going to give the maximum number of time he can keep up the candles. He can light up his room the maximum number of times. So let's look at the logic for this problem. So initially, the burnt candles will be 0, obviously, and the initial total hours will be the current A, the current value of A, because at the beginning, if we are given, let's say, some integer 5, we are given 5 candles, so we can burn all the 5 candles for 5 hours straight. So initially, whatever value the A has, initially total hours that will burn, that the candles will burn, will be equal to current value of the A. After that, after we have burnt all the A candles, all the current A candles are converted into the burnt candles. So burnt candles will be the current value of A candles. After burnt candles, how are we going to calculate the next number of A, the next batch of candles that we can make out of these burnt candles? It will be calculated by the number of burnt candles upon B. B will be the number of candles required to make one new candle. So the amount of burnt candles divided by B will be the number of current next batch of candles that we are going to use. And also there is one more thing. For this problem, we have to also calculate the number of unburned candles, meaning uh, let's say we have a test case of 5 and 2. We are given 5 candles initially, and we require B 2 candles, 2 burnt candles to make a new candle. So let's say we burn 5 candles for 5 hours. After that, we require 2 as an initial value. So after burning for 5 hours, we'll have 5 burnt candles, out of which we can use 4 and make 2 new candles. But there will be one candle which will be unused for that case. But in the next case, if we move on to the next case, so in that case, we'll use 2 candles. So the current value for the second iteration will be 2. So overall value will be 5 plus 2, 7. After that, we have one unburned candle, and since the second value will be 2, we'll be burning 2 candles. After 2 candles are burned, we'll get one candle from these two and one candle that was unburnt in the second case. So after combining these two, we'll get one more candle, and the total number of hours will be 8 hours. So it is written in the question that we have to maximize the number of time we can keep the light in the room using candles. That's why we have to keep a trace of current candles, of burnt candles, and the number of candles that are left unburned. We have to trace all these three things in order to maximize the number of hours. So let's take a simple test case here and understand our logic. So I've taken A for A is equal to 7 and B will be 2. So in the first iteration, our current A will be 7 and current B will be 0. Since initially we are not burning any candles, so burn candles will be 0 and the candles that we have will be 7. So after we burn all the 7 candles, it will be of 7 hours of light. After that, the burnt candles that we'll have will be 7, and here we'll calculate the current A values which will be used in the next case. So the current A value will be 7 burnt candles upon the candle number of candles required to make one new candle, which is given 2 in this case. So 7 upon 2 will be 3, since there will be one unburnt candle left, and we'll use a pair of 2 2 2. There will be 2 pairs. We'll use that to get 3 new candles which we can use for the next 3 hours. And here, that's what I was saying, we are going to use modulo operator to check to calculate the number of unburned candles, and we'll just feed it right into the current number of B. Why are we using the modulo operator is that, let's say uh, if the current A is totally divisible by the current number of required candles, let's say we had 6 instead of 7, so 6 upon 2 will be 3 and 6 modulo 2 will be 0. So the number of unburned candles will be 0. But for this case, we have one unburned candle which is being left, and we have, since I have discussed earlier, we have to trace all three things: the current candles that we have, the number of burnt candles that we have, and the number of unburnt candles that are being left. We have to trace all these three things. And for the second iteration, the value of current A will be 3, which we have calculated here. So the number of hours these 3 candles will burn will be 3. So the number of hours will be incremented by 3. The total number of hours that we currently have in the second iteration will be 10. After that, the current number of B will be, since we have calculated here 1. Yeah, so it is mentioned here that the burnt candles will be assigned the value of the current candles. So for the second iteration, the value of the current candles is 3. So the value of B will be 3 And additionally, there was one value, since the code works in this manner, like upside down. So, since the code works from upside down, so the last value of current burnt candles will be one. So we have to add value of B to the value of A that we have in the second iteration. So the number of burnt candles that we'll have will be one. One is unused candle from the first iteration. We'll be using that unused candle in the second iteration to make one more candle. So the current value of A will be current value of B upon 2, which will be 2, and the current value of unburned candles. That's what I've discussed earlier. Since it is an modulo operator, since it is completely divisible by 2, there will be no unburned candles, so none of the candles are being unused. So let's move on to the second iteration. Here the value of B will be 0. After that, for the third iteration, the value of current candles that we have will be 1 that we have calculated in the second iteration. The total number of hours these two candles will burn will be 2. Last, in the second iteration, we had 10 hours. So we'll increment it by 2, which will be 2 hours. So since the last value of B was 0 and the current value of A is 2, after burning all the current candles, we will get 2 unburned candles. And since there was no candles left in the last iteration, so we'll just add the value of current candles, which will be 2. After that, we'll calculate the value of A for the next iteration, which will be the current burnt candles upon the candle required to make a new candle. After that, we'll calculate the number of candles that are being unused. In this case, there is no candles that is being unused. Let's move on to the fourth iteration. In the fourth iteration, the current candle that we'll have will be a single candle that we're going to have. The hours will be incremented by 1, since in the third iteration the hours we had was 12. After that, the current value of B will be 1, since the current we had only one candle to burn. So the current value of burnt candles will be only 1. After that, we'll calculate A. And one more thing, we'll uh, till uh, till when should this iteration should last? So the edge case for this iteration should be until and unless A becomes 0 or less than 0, which will be a negative integer. So as long as A is 1, we can still burn one candle. And if the value of A current candle falls as in negative integers, we won't be able to burn any candles. So we are going to iterate until A becomes an negative integer. Moving on to the fourth iteration, the current value of burnt candles will be 1. Next, calculating the value of current candles for the next case, it will be 1 upon 2, which will be evaluated as 0 or negative integer, and the current value of unused candle will also be 2. So at the last, we are just using this modulus operator to calculate the number of candles which were not used uh, uh, in making the next candles in making the candles for the next iteration. That's what we have used the modulo operator to calculate. So this was the logic for this problem. Let's look at the code. Yeah. So here I've taken A and B, which was given as input. I've initialized current A, the current number of candles as A, and the current number of burnt candle as 0. Initially, the current number of hours will be 0. And as I've mentioned earlier, the iteration should last until and unless the number of candles becomes 0 or it should become a negative integer. As soon as we enter the iteration, the number of hours will increment by the number of current candles. After that, we are calculating the number of burnt candles, which will be the value of current candles that we had burnt for the hours. After that, we are calculating the number of current candles, which will be the amount of burnt candles that we have upon the amount required to make a new candle, which is B. And at the last, we'll be calculating uh, using modulo operator how many candles are being unused for this iteration, so that we can use that unused candles for the next iteration. So let's try to run this code for the case that we have taken. So this is problem number 379A. The test case that we took was 7 and 2. We're getting 13, and that was the last answer that we got. So the maximum number of hours that we can burn all the candles, reusing all the candles, will be 13 hours. We won't be able to use any more candles after 13 hours. And let's take one test case from the problem itself and check if our logic is correct or not. We are getting 7, and that's 7. And let's check this test case. We are getting 8, and in the problem it is also given 8. So this was all for this problem. It was quite easy, but you just have to keep in mind of the modulo operator. I forgot about that. That's what kept me repeating the problem. So that's all for today. Thank you.